And finally, it's time to find out who is the better: Pepsi or Cola, Harry Potter or The Lord of the Rings, Star Wars or Star Trek. In this video, we will compare what the best place to store your data inside Forge app. Is it entity properties or Forge storage? What the best place to store configurations, some objects which you need for your app inside Jira or Confluence. To do that, we will make a comparison. I hope you remember last time in the previous video we discussed all the possible places where you can store the data inside Forge app. It could be entity properties, Forge storage, attachments, and some remote sources. And we find out that the best place for this is entity property and Forge storage. But what's the fastest one? Which one is the most reliable and which will return data in the most efficient way? Let's find out. How we will do it? We will make the app which will compare these two options. So, first of all, we will make the function which will continuously repeat some calls. For example, get operations for Forge entities or set operations for Forge entities, and we will repeat it x times, 100 times, for example. The same we will do for entity properties. We will do 100 get requests, 100 set requests. Then we will compare the results to find out who is the faster one, which type of the storage most fit from performance point of view. I've built this app already. For you, it's pretty simple app. It's just using one Forge module which called WebTrigger. Why? Because this module is working on the backend side of the Forge. It allows you to make directly calls from Forge infrastructure to Jira Cloud infrastructure. It means that you can avoid any communication with the front end, with your connection, and we can avoid checking your internet connection. So the calls from the WebTrigger will be directly goes to the Jira Cloud instance without communicating with your instance at all. And we wanted to make this check as simple as possible. There will be no any validation, no TypeScript, no tests, no other things, just a pure checking of the performance of particular functions. If you will have a look at the sources, it has only one file, this index.js. It contains the functions which we will use to test entity properties and storage. The entry point of this script, this run async function which exported and connected here to manifest through the function module. So when we will call our WebTrigger, it will call this async function and will do all the checks. Initially, I wanted to try to combine all of them into one check to test it one by one, but I've realized that it works not well, and invocation timeout of 25 seconds or something is not enough to check all 4 functions. That's why I've split the function to 4 different ones. And for test the performance, you need to execute this function 4 times. One for issue property set check, issue property get check, storage set, storage get, and so on. So we will execute it 4 times and we will get 4 results for every function separately. Then we can combine it together using magic of Excel or whatever you like and compare the results. To start, what you need to do, I've explained it here in the README file. You need to install all the dependencies, register the app with Forge register, so it will generate new unique ID here and it will makes the app available in your development console. Then you need to deploy it, install it to your cloud instance, And all these steps are pretty self-explainable, and I've already discussed them in the previous videos, so just watch one of the previous videos. The most important step is here, it's Forge Web Trigger, because this step allows us, let's type it, Forge, allows us to get the URL of the web trigger. It's interesting. Every web trigger on every instance has unique URL. Atlassian did it for security purposes, first of all, because web trigger doesn't require any authentication. It works on the app level, not on the user level. It doesn't know about current user anything. So that's why it's not it's important to keep the URL of your web trigger secured. So we just need to define on which instance we are going to generate this URL, for which module name, we have only one, and it will give us the URL which we can use to execute our web trigger. Let's try it. I've already deployed my app, so I can just copy it and go to my browser. If I will just execute it, it will not work properly. Why? Because we need to define some parameters. The parameters explained here in the usage section. We need to define variable for check, so which check we are going to use, which issue we are going to use for our testing, which property key, and how many repetitions we will do for particular check. I've already prepared the parameters there, so I just need to copy it, add it to my trigger, and be sure that I have the issue which I'm going to test. I've decided to use issue entity property just because the most common one available, the easiest, they're easy to use and no issues to show it, for example, but it will work the same for project entity properties or board entity properties or gadget entity properties or any other entity properties. Let's just type it. Let's have a look. So web trigger now is executed. It will do how many? 100 repetitions for set issue property check, and we will get the result of this execution. Bam. Let's have a look at the raw data. First of all, the result is a JSON file which shows us which check we applied, how many repetitions we had, what's the average time for this type of the check, what's total time of all the checks, and particular time of every from these 100 checks in milliseconds. It's important. All the time in milliseconds. It's more than enough to compare the time of executions, and we will use later all these execution times to maybe draw some nice diagram to see how often which categories of requests we have and how long it takes in average to have this set type of check. All right, it works pretty well. Now I will execute this web trigger 3 more times for other checks and then compare the results in the Excel. And now the results. You can see, as you can see, set operation for issue entity properties in average take 200 milliseconds. So it means we can set entity properties of random size. I've checked it with empty objects, with 1 kilobyte object, with 10 kilobyte objects. It's almost the same, not much differences. and you can read the same amount of data with various object size in about 150 milliseconds in average. If you have a look at the distribution of time of this execution time, the most of them for the set operation is about here from 150 to 200, whatever, 10, 20. And the most of the read operations, so get operations, starts from 130 till 160, so in this range. But the most interesting question, what about for storage? Is it faster or lower? So you can still, you have a chance to guess. 3 to 1, let's have a look at it. And I was a bit surprised, because time of write and read operations for Forge storage is more than 2 times faster. So it's 2 times faster than entity property. And in average, set operations take about 90 milliseconds, and read operations even lower, it's about 70 milliseconds. And you can see the write operations is somehow very consistent, the same execution time again and again. For read operations, the discrepancy a bit higher, and you can see here the time starting from 56 milliseconds and up to even 100 milliseconds, which is pretty interesting. But nevertheless, we can definitely say that Forge storage is our winner, and if you need to store a lot of data with multiple read and write operations, the best option for this definitely is the Forge storage, because both get and set operations works more than 2 times faster than for entity properties. Thank you for watching. As always, link for the repository you can find in the description for this video. Try it by your own, share your results. See you next time.